And then share the desktop. Okay, so for today, over the weekend, you practiced with dictionaries, which we looked at in class last time, right? So basically your assignment was to do pretty much what we had already done in class. Messing around with dictionaries, understanding how they work, kind of recognizing these guys are a new type of collection for us, which allows us to have, you can almost think about it like a variable environment where we can have a whole bunch of name value pairs where we can say, give me the value associated with a particular variable name, and it will spit out that value. We're going to be using that some today as we write some code that does some interesting stuff that we learned earlier in the semester. But in any case, we want to think about that collection as being a precursor for us to objects, which we haven't learned how to write yet, but at this point, we, like for us, the assignment today, we knew how to store a person's first name, last name, and age, for example, which are three pieces of information we may want to store about something. In this case, we decided that's what we want to store about a person. And last class, earlier in the class, we looked at, well, we could accomplish that with lists, right? We can just say, well, I'll put it bucket 0, the first name, bucket 1, the last name, bucket 2, the age. I'll just have to remember that's where I put those things, right? That way, if you go to print out their first name, you don't look at bucket 2. You look at, what did I say? Did I say first name? Bucket 0 for the first name, whatever it is. So there's the example why you don't have to you don't want to have to remember it. So dictionaries allow us to have the allow us to not worry about the order things are stored in. That's something dictionaries don't promise us. They don't say bucket 0 holds this, bucket 1 holds this. I think we saw last time that it appears like they do store them in the order we put them in, but at least this particular Python interpreter, but there's no guarantee of that. So dictionary would be the right tool for the job when we want to store a whole bunch of name value pairs, but order isn't important. It's being able to get the information out. That's important. Okay, so what we're gonna look at today is we're gonna try to put some of these things together. We're going to try to put some of these things together that we've been working up to this point, and then we're going to start talking about variable scope a little bit more, which I think I started talking about. I don't know if it was last class or the class before. So I'm going to get rid of all of our stuff in here so far. Now, something that I don't think we haven't written any programs yet that convert from binary to decimal or any of that stuff, right? We talked about how that all works. So now what did we do? We learned in class, okay, here's two different patterns. One pattern from converting between any base and decimal, and then another pattern from converting between decimal and any base. We could take a decimal number and convert it into binary, for example. So we talked about those things and practiced them and things like that, okay? So we kind of got this algorithm in our head on how we can accomplish that, right? If you kind of recall, if we go back here to our slide in here. Actually, so let's say I wanted to take the decimal number, I don't know, 39, decimal to binary. What did I do? That was the pattern where we kept dividing it by 2, right? So we would take 39, we would divide that by 2, and 39 divided by 2 gives us a what? 9? Not a 9. 19, which gives us a 38 with a remainder of 1. 19 divided by 2 gets us a 9 with a remainder of 1. 9 divided by 2 gets us a 4 with a remainder of 1. 4 divided by 2 gets us a 2 with a remainder of 0. And a 2 divided by 2 gets us a 1 with a remainder of 0. 1 divided by 2 gets us a 0 with a remainder of 1. And then we read our answer from bottom up. So this is 1, 0, 0, 1, 1, 1 is the binary version of the decimal number 39. All right. So any questions on how we just did that? Let's review. We're looking at something we've already done. But first thing to solve any problems, we need to understand it as a human being. So do we understand what we have to do to convert a decimal number to a binary number? Okay, so now the next task we're going to try to do is we're going to say, you know what, that could kind of get a little tedious. It would be nice if I could write a program that would do that for me. You know, we kind of look at this in a little bit more detail. We say, you know what, I kept doing the same pattern over and over and over and over again until I finally got a 0. That was my stopping case. So I'm going to repeat something over and over and over again until I get a 0. That make sense? Okay. So now what we want to do is we want to say, I want to try to capture this idea in, I want to capture this idea in our case, Python. We want to write a computer program that does this. We want to write a function that I can pass a decimal number to, and it will spit out the binary equivalent for me as a string. You know, so we think about this as like building up the string 1, 0, 0, 1, 1, 1, something like that. Okay. So we're going to write a function we're going to define, and let's call this guy decimal to binary. And he'll take in a decimal number in as a parameter. All right, so we want to take our algorithm now and turn it into a Python code that does something. We know we want to do something over and over again until something whittles down to 0. So if we go back to this, we're basically saying 39 is kind of like our decimal number, right? We named it DEC here, Des. So we want to keep going. 39 became 19, became 9, became 4, became 2, became 1, became 0. We want to keep going as long as decimal is greater than 0. Make sense? So we want to repeat something over and over again. So we're going to say, while des is greater than 0, let's do some stuff. Okay? Go ahead.
Did we need parentheses around des and greater than 0, or is that not necessary?
I don't know if it's necessary or not in Python. I always put it in there. I think it is necessary for a while loop. I think it'll scream at us if you don't put that in there, but not positive. Okay, so we do have a result we're building up here. We might look at that and we might say, well, how am I going to represent that result? I mentioned a minute ago, maybe we do this as a string and we build up a string. How do we build up strings in programming languages? Go ahead. Yeah, through concatenation. So before I even start my loop here, maybe I'm going to create a variable called answer. And I'll start it off as the empty string. I don't have any bits yet to put in there, but I'm going to put some stuff in there as I go. Make sense? All right. Now, I'm going to need 2 mathematical operators here. And we've practiced with both of them in the last couple of weeks. We're going to need that // What does that guy do? So if I say 5//2, what will that get me? That'll give me 2. So 2 slashes gets me integer division. So if I just kind of write it here, this gives me a 2. 5 divided by 2 will give me a 2.5. That's not what we want here, right? We want the integer division. So a 5//2 is a 2. How do I get the remainder 1? Yep, so 5 mod 2 will get me that 1. So this is 2 remainder 1. That make sense? All right, so this guy is not going to be helpful to me in this particular operation. And let me actually just test something here right quick. 5 divided by 2 gives me a 2. 5 mod 2 should give me a 1. It does. Okay. I think it's Python 2.6. It's 5 modulo 2 to get you the, one of them uses modulo, the other one uses the more traditional percent symbol. Basically, in all your C-based languages, your modern languages, percent will be modulus. So C, C++, Java, C#, Swift, Objective-C. Did I forget anything from that list? Yeah, all those. Pretty good guess that percent is going to give you the remainder. Okay, so these are the two little math tools we're going to need to solve this problem. Okay, to accomplish what we saw here, we're going to need to do some division and we're going to need to do some modulus. Well, what are we doing? We're recording the remainder and then we're getting our new version of decimal. Okay, so I'm going to actually go ahead and put this in a variable here just so we can walk through it. So I'm going to say the remainder here is going to be whatever decimal currently is, mod 2. And we know we're modding it by 2 because we're converting to binary, and binary is base 2. If we were doing this for one of the other bases, we'd be looking at this a little differently. Okay, so that's my remainder. Now, after I have my remainder, now I can whittle decimal down. So I can say decimal is equal to whatever it's currently equal to divided, integer division, by 2. But notice I've recorded my remainder first because I need that remainder before I whittle it down. Because once I whittle it down, the remainder might be a new remainder, might be different than the previous one. So I need to get my remainder first. So I got this remainder 1 before it became a 19. I got this remainder 1 before it became a 9. I got this remainder 1 before it became a 4, and this is the best place to see it. So had I not gotten it beforehand, my remainder would have been a 0 instead of a 1. So I need to record my remainder first, then I can whittle it down, because it's that remainder I'm going to be using to build up my answer. That make sense? Okay, so we're going to keep doing this math over and over and over again until we finally whittle dec down to 0. And as soon as it's equal to 0, we're no longer greater than 0, we will fall past our while loop, and we want to then, in our case, return our answer. Presumably, our answer has been built up inside of a variable called answer. We haven't built it yet, but that's presumably what we're planning on doing, right? So I'll come in here and I'll say return answer. So what I need to do in here is I need to say, what do I need to do to build up answer with my, effectively, my collection of remainders? That's what answer is, right? It's a collection of remainders here. So I'm going to say answer is equal to something. Now I'm going to do it the wrong way first. All right, then we'll back through it. So I'm going to say we're going to concatenate on to answer. So I'm going to say answer is equal to answer concatenated with. Now, Python's only going to view this plus sign as the concatenation operator if what is true. Only focus on this line right here. This plus sign is only going to be treated as the concatenation operator instead of the addition operator if what is true. Go ahead. Yeah, if this side and whatever I put over here is a string. So remainder is what kind of value right now? Yeah, not a string. So how can I turn remainder into a string? See if somebody else gets it. Do I have a tool that allows me to turn like the number 5 into the string 5? Parentheses int goes the other direction. So if I say int 5 like that, I will get the number 5. So I want the other direction. So if int turns a string into an int, what do you think will turn an int into a string? Okay, formatted string. Yeah, so the function is called str. So str this guy, I can drop a 5 into, for example, and it will give me the string 5. Yeah. Yeah, it's not a bad guess. I mean, because we're dealing with strings giving us a formatted string thing. So this function right here lets me take something that's an integer and turns it into the equivalent as a string, which will then allow Python to treat this as concatenation. That makes sense? If we were working in languages like Java, C++, C#, we actually would not need to convert it. Those languages will treat this as the concatenation operator if at least one side is of string type. Python requires both sides to be string type, has more to do with the way interpreters work, the way they implemented it. So just is what it is. So what we're going to say is we're going to concatenate on the string version of our remainder. Go ahead.
If I had up where you have remainder equals, if I put string parenthesis around this decimal module.
Yeah, you'd get it as a string then.
Okay.
Yeah, so he's saying, what if I did this? Yeah, at the end of the day, what are you doing? You're making sure this value is a string. You could do it beforehand. I mean, the downside to doing it, in this case, I guess there isn't a downside, but the downside to doing it up here is then you don't conveniently have access to that guy as an integer if you needed it as an integer. So I would say don't over manipulate variables unless you have to. In this case, we need him to be a string, so we're going to make him a string. All right. Now, what we're doing right now, if you kind of go back here, you saw that in the end, we read our answer from bottom up. But what we're doing right now is we're actually building our answer backwards. So right now, we're currently building it forwards. We want to build it backwards. So right now I'm saying 1 has a 1 concatenated on the end of it, has a 1 concatenated on the end of it, has a 0 concatenated on the end of it, has a 0 concatenated, has a 1 concatenated. So my final answer would be 1, 1, 1, 0, 0, 1, which is not the correct answer. I need to build it in reverse, or I can build it the direction I'm building it now, and then I can reverse it later, right? So let's just keep going down that path right now. All right, so we have our answer here. Let's see, did I introduce our new template for our programs last time? Did I have something like name equals main? I think I talked about the idea of main. Okay, we'll introduce that. Actually, let's just introduce it now while we're at it. So I'm going to throw something in here. It's going to say if underscore underscore name is equal to underscore underscore main. And then I'm going to call a function called main. Now I'm going to write a function called main here. Ay, ay, ay. Because remember we were talking about variable scope? I think I had a picture, didn't I, with like colors and stuff? This guy. So you're talking about variable scope, and we have this global scope thing here that exists. So I'm kind of talking about 2 different concepts here. I just want to take advantage of this while we're sitting at this point. So what I have there in, what was that, yellowish orange? Whatever that is. That is everything in here. We have this global scope that governs everything that's in there. Now, with that, we have this problem where we can't compartmentalize our scopes, where we might have one variable that we break because we changed it inside of one of our functions, but it was actually a global variable. So what makes more sense is to have these individual blue scopes and have those live in and of themselves. And if every now and then we do need a variable that we want to have shared among all of the individual scopes, that's great. We know we have a place to put it. We could put it inside the global scope and then everybody has access to it. But that should be the exception, not the rule. So kind of an old school saying in computer programming is that global variables are bad. I don't know if I would necessarily agree with that. I would say global variables are situationally good, something along those lines. So I would operate from the guise of never create a global variable unless it really, really, really benefits you. And don't confuse benefits you with, oh, it just works. Those are two different things, right? Because again, I want you to kind of think about some of the things I keep harping on is, don't run code until you've thought about what it should do. Because, I've said it a bunch of times. I don't care if your code's working yet. What I really want you to do is I want you to see the 50 things that don't work. That's when learning is taking place when you're working on your homework assignments, right? You just got it right the very first time, then A, you probably have already mastered the subject, mastered that, the concept you're working on. Great. Mission accomplished. Let's move on to the next ability, right? Otherwise, if you're sitting there banging on the keyboard, trying everything under the sun, you're learning all those things that don't work. But never hit play unless you're going to be able to say out loud what you expect this to do and why that change you just made you think will make a difference. That way you don't fall prey to this idea of trying every single permutation of code until it magically functions and you have no idea why. That's the secret. The secret sauce is the why, not the result. The results will come. This goes right back to the first week of class when I talked about this kind of being like a sport. So pick your favorite sport, basketball, tennis, golf, football, whatever it is, some skill that you're learning in there, you academically learn it early on, but you can't execute it. And until you've practiced it a bunch of times, when you finally start getting the results of that practice, that's when you get your reward, right? But you still do those little drills that feel stupid in the moment, but are actually the building blocks of building that skill in the end. When at the end of the day, then it's just, you don't even think about those, the little micro skills, you just do it. It's muscle memory or whatever you want to call it. All right, so we don't care about the right solution yet. We'd love to eventually get the right answer, but we care about the journey because that's where the learning is taking place. If you're going to spend 2 hours in your assignment, you might as well get something out of it, right? Because the worst thing to get out of it is 2 hours where you ultimately have the right answer and you've learned nothing. I'd rather you get the wrong answer and learn a lot, and then maybe have a better shot at getting the right answer next time around, something like that. All right, so part of what's going to help us do this is to say, this goes back to this idea about the global scope. Use the global scope when it is to your advantage, but for a good reason. If you have a single variable here, that it would be beneficial for all three of these scopes in here to have access to. You got two options. You could pass that value to each of those functions, but if it's really something you say, you know what, they all kind of need to know this one value, and any changes that one of them make, the other one should know about it as well. Why inconvenience yourself by having it get passed around when you could just put it in one central location? We see the same thing in real life, right? So you might text message your friends or have a Facebook group chat or something like that. You specifically have a group chat because you have the 2 or 3 or 4 people in there that you want to communicate the same message to, as opposed to having to text 4 different individual people every single time you want to send a message. That makes sense? That's like a global variable. Like, well, I mean, sometimes then what, you make a mistake and you send a private message inside the group message, and you didn't mean to do that, and you're bashing on somebody else's in the group message, and then you make sure that you act like it's funny. But in any case, this is kind of the same idea, is that you decide when does it make sense, and that's when you should strategically use something like that, but don't use it as the general rule. So to kind of force us down this path, our new format for our programs is going to have at the bottom this line that looks like this. It actually isn't even required. If you just make a call to main down here, it'll just work. But this basically, I've made this comment before that all programs begin and end with main. Inside of Python, we have a couple of these specialty variables that start with __, like this. And we're going to see them come up more when we start getting into writing our own objects. But you see these __ things, and we're asking if The name of the function that was called by default is __ main. All programs begin and end with main. If that's a true statement, which I'm telling you it will be, right? Because all programs begin and end with main, that's a truth. So in Python, it's all programs begin and end with __ main __. They mainly put the __ so that it wouldn't conflict with the variable names that you made yourself, unless you came up with some really freaky deaky variable names. The guy just put double underscores before and after all my variable names just to be dangerous, right? So, what's up? It would yell at you and said, this is a reserved word. Yeah, somebody would say, this is already taken, you can't do this. You can't redefine something, it's part of the language, but they're trying to be nice to you and say, we'll name ours a little bit weird so that you have to go out of your way to possibly conflict with us. Make sense? Okay, so this is kind of our, more of the proof piece here. I just want to do this line. That part is actually not required here because it's assumed since we aren't checking anything else. There are some other names that could get called that we're not going to deal with in here, but for us, I'm putting it here just to show that if the main method was called, what are we going to do? We are going to specifically call a function that we wrote. We can call it elephant if we wanted to, but I'm calling it main to really drive this point home that all programs begin and end with main. So I wrote a function called main that is going to be the driver for my program. And that guy right there is going to be like one of these blue boxes. He has his own local scope that's protected from the other ones. So this will get us into that mindset of not relying on global variables. If I have something that lives in main that I need to get to decimal to binary, I will have to pass it through a parameter, not just rely on it magically being available from the global scope. Okay? And this mentality is going to serve you well for, this is how programming really works. That global scope in Python is almost an accidental convenience. All right, so I'm going to go ahead and call my decimal to binary here, passing it a 39. I'm going to print the result, and we're going to see it's going to give me the right answer-ish, but in the wrong order. So there's my 111001. Okay, so now what could I do to my code up here to fix it? Well, I could go ahead and say, well, I'm going to go ahead and define a reverse string. I think there actually is a reverse string that already exists, but we're going to pretend like we don't know that. We're going to call a reverse, we have a reverse string method. It's going to take a string as a parameter, and we're going to build up a new string that is that string in reverse. So I'll just name my answer again, answer, just giving it a variable name. And I'm going to walk through that string backwards. So I'm going to say for I in range, the last legal bucket in S is the length of S minus 1. I'm going to go down to and including 0. So I need to go down to -1. Remember, the second value is non-inclusive. And I'm going to take a step of -1. So if my string had 5 elements in it, the legal elements are 0, 1, 2, 3, and 4. So this is going to go from bucket 4 to 3 to 2 to 1 to 0, including the 0. The -1 would be my stop point. And I'm stepping by -1. I went from the 4 to the 3 to the 2 to the 1. So this is our for loop that will walk through a string backwards, starting with the last legal position in that string, going all the way down to and equal to 0, since it does not include that value. And I'm walking backwards by -1. And then what will I do? I'll say answer is equal to answer concatenated with S at bucket I. And then what I can do here is I can say, well, let's just go ahead and call reverse string on my answer before I return it from decimal to binary. I built it in the wrong order, so let's just reverse it by having the second tool that knows how to reverse a string. Oh, never actually returned my answer here. I did reverse it, but I do want to return my answer when I reverse it. So there's my reversed version of that, 1 0 0 1 1 1. That makes sense? Now, this is one way we could have accomplished it. In fact, we can say, you know what? This is a reasonable tool. Now that we have a tool that can reverse a string, I could use that sometimes, right? It's something you can throw into your toolbox and say, that could be handy. Like I said, I think there is a string reverse function that exists in there. I don't remember if it's, let's see, it would probably be, let's see, hello dot reverse maybe. No. Reverse hello string dot reverse. I'd be very surprised if it doesn't exist. It's probably in one of the libraries. But in any case, rather than sitting there and guessing, what did we do? We just spent a minute and wrote our own. Definitely have one now. Go ahead.
We go through for I in range, length, last bucket, the whole line right there, line 11.
This guy?
Yeah, can you just walk through that one time?
Sure. So this guy right here, range, it produces for us a list, right? A list of a bunch of values. And it has I equal each of the values in that list. So if my range here, the length of S, let's say S was a string that had 5 characters in it. The length of that is 5. 5 minus 1 is 4. Now I want to go down to, so remember the second element of range says go to this value, but not including this value. And I'm stepping by -1 instead of by 1. So this is going to go from 4 to 3 to 2 to 1 to 0. That's the list it will produce for me. That I will be each of those values. So I will be a 4, then it'll be a 3, then it'll be a 2, then it'll be a 1, then it'll be a 0. And then it will step down to -1, but -1 is not greater than this. So it'll stop. So this is the collection of numbers that this range function will give me if S has 5 characters in it in our example. Does that make sense? All right, so I could do this. I could see, oh, well, my answer was in reverse, so I'll just go ahead and write a reverse string function that reverses it back. Or I could have just built my string in reverse. So rather than concatenating something onto the end of my ongoing string, I concatenated it onto the front of my ongoing string. I built it in reverse. So now, even though I have this untapped resource here, I'm no longer calling it, and we see that we still get the right answer. Because it might be helpful. We might need this reverse string at some other point in time, right? Might as well leave it in our toolbox here. But whenever you need it, you saw it's not that hard to write. It's a good thing to practice writing because that's our loop that spins backwards. You know, you could also write another version of reverse string. You could say reverse string 2. And this guy could take answer as the empty string. And rather than go through our string backwards, we can just say for C in S, this will go from every character inside of S, and we'll say answer is equal to C concatenated with answer. Return answer. So now we see we can call reverse string on hello, and it'll give us hello backwards. Reverse string 2. Because what did I do? I went through every character in S in order. If you want to see another version of this that uses the range, we'll call this reverse string 3. We'll say for I in range of 0 to length of S. the default version of range. We want the string, actually we want, we don't need the string version of it. We'll take S at bucket I, because that's already a string type, and we'll concatenate down to the front of answer. So that's our reverse string 3, and we see that also still reverses it. So 3 different ways to reverse a string. We can walk the original string backwards and build up our answer. We can walk the original string forwards and build up our answer in reverse. We can walk our original string forwards, not using the index, but using each character in a collection, and build up our string in reverse. All 3 of those ultimately reverse our string. Does that make sense? 3 different ways of accomplishing the same thing, and they're very related to each other. They're all involving concatenation. We're just building up our string in the right order and going through our string in either forwards or backwards, and then operating with that correctly based on what we're trying to accomplish. But in this particular case, we didn't even need any of these reverse string things here, because I could have just said, you know what? Why don't I just build my answer in reverse up here when I was building it? I know it needs to be reversed, so why don't I just build it backwards? So I just flipped answer. Instead of answer plus string remainder, I said string remainder plus answer. All right, that makes some sense? Now, what if I wanted this to be decimal to octal? So define decimal to octal, taking in a decimal number. What would I change in this guy to make it the octal version of this instead of the binary version of this? So octal is which base? Base 8. So instead of dividing by 2, what am I going to do? Divide by 8. And there we have the decimal to octal version of this. What if I want decimal to hex version of this? Actually, the fun one is decimal to decimal version of this. That's when I divide by 10. So if you run this, decimal to decimal of 2,346 should get me what? What's 2,346 from decimal to decimal? 2,346. Still works. Pick your favorite big number, converts it from decimal to decimal. It's going through all that math, doing all that crazy stuff just to give you the same answers you had before. Technically, it's as a string. Proving that this pattern works. I'm going from base 10 to another base. Nobody said that other base can't be base 10. All right, the pattern functions. What if I wanted to do decimal to hex? What base is hex? 16. All right, so right off the bat, we might say, oh, well, now we're dividing by 16. But is that all we have to do? I'll copy this. I'll show you my favorite decimal number to hexadecimal. So decimal to hex is 2989, which should give me BAD, right? But what does it actually give me here? It gives me an 11, a 10, and a 13. It gives me the right values. The B, the A, the D. We know as humans, we can look at that and says, oh, I forgot to do something. But it doesn't convert the 2-digit answers into the single character answer. So I need to have a way of taking an 11 and making it a B, having a 10 and making that an A, having a 13 and making that a D, having an 8 and having that stay an 8, right? How might we accomplish that? Go ahead. Okay. All right, tell me more. So you want to create some variables.
That's all I got so far, but it's gonna read that as a 1 and a 1 and a 1 and a 0 and a 1 and a 3, right?
All right, so let's say that I have an 11. I have an 11, and I want that 11. Actually, let's just go over here with it. I got to jump far ahead in our things because I already covered a bunch of this stuff. So let's say I have an 11 in decimal to hextet. So I want to convert an 11 to a B. I want to convert a 4 to a 4 because 4 is a legal hextet, right? I want to convert a 10 to a A. So how do I write a program? If we're just thinking about this, I should have a program that should be able to take in values between 0 and 15 and produce 0 through 9 and A through F. It converts the digits from the decimal number system into the hextets of the hexadecimal number system. So if I were to write a function that does this, what would that function look like? So what we call this digit to hextet. Don't think about the bigger picture at this point. All we're saying is if I give you an 11, you give me a B. If I give you a 10, you give me an A. If I give you a 7, you give me a 7. If I give you a 15, you give me an F. You're converting between a decimal digit or a decimal number and its equivalent hextet. Using only the tools that are currently in our toolbox. Because we solve all problems using the tools currently in our toolbox, right? Go ahead.
I mean, the only thing that I can think of right now is like A equals, or yeah, A equals 10, B equals 11, equals 12, and so on.
And just ask the question. Like if it's greater than 9, if it's less than or equal to 9, just return the value. Okay, so let's write this bad version. That's okay. Hey, it still will work, right? So we'll define, call it digit to hextet. This guy will take a digit in as a parameter, and we'll say if digit is less than or equal to 9, just return it. I don't need to do anything special. Now, realistically, we're probably wanting to return the string version of it since the other guys are going to be strings. So I'll go ahead and return the string version of that digit just so this function always returns the same kind of value. So if digit is less than 9, less or equal to 9, I could just return it. 0 in digit is the same as 0 in hextet. 8 in digit is the same as 0 is 8 in hextet. 9 is the same. 10 is not. Okay, so if I'm in this else, that means it's something other than a 0 to 9. So we could say elif digit is equal to 10. You want to return an A.
Then you just have to print that out for every letter.
B, C, D, E, and F. 11, 12, 13, 14, 15, B, C, D, E, And we could test this guy. So we'll call digit to hextet. If I give it a 10, it'll give me an A. If I give it a 7, it'll give me a 7. If I give it a 15, it'll give me an F. Seems to solve the problem we wanted to solve, right? So now I can come in here to my decimal to hexadecimal. And instead of taking my remainder and turning it into a string, I'm going to call digit to hextet of my remainder to make sure I get the right values. So now when I say did a decimal to hex and I give it 2989, it will give me my BAD. Make sense? Go ahead.
I just have a question. How did it know to compartmentalize the 11 and the 10 and the 13 together? Like, why didn't it read it as 1, 1, 1, 0, 1, 3?
Well, it did. So right here, my remainder was an 11. What I have highlighted there?
Just one at a time. Sorry, it doesn't looking at each one.
Well, no, I mean this would
decimal divided, right?
Yeah. So I got a whole. It was 11. Yeah. So this was an 11. I passed an 11 into this factory. That factory said that's a B. So it converted it to a B for me. All right, but we want a better way of doing this. Not that we need a better way of doing this, because realistically, is this acceptable? I mean, that's not like a ridiculous amount of code, is it? We did a lot of cutting and pasting. I mean, it wasn't that bad. We can look at that and say, there's probably a better way, right? There's probably a better way, but hey, it's crunch time and you just need it to work. Nothing wrong with this. But let's look at, I'm going to give you a hint and then let you think about it for a second. Let me get to our hint slide. So we're thinking about, so again, this goes back to this thing where we solve all our problems in terms of the tools we have available to us, right? So all of us during this first, what was this, week 5? What week are we in? Whatever it is. Okay, so in the last 5 weeks, we've gathered some tools for programming, right? And so we need to solve all of our problems right now in terms of those tools. So I'm going to land on a slide like this, find. How could we leverage this tool to allow us to solve our decimal or digit to hextet problem? Remember, how does find work? Find shows us the position where a character was first found in a collection, or it returns a -1 if it was not found. Okay, so take a couple minutes and think about how we could use the find function to make it more convenient for getting our digit to hextet, or decimal to hextet is probably the better. Technically, an 11 is not a digit, it's a decimal value. All right, so any ideas? How we can use the find function to help us accomplish this? Good.
I mean, I have an idea, but it's not fully thought through. You can take the string version of the answer, right?
Which answer?
The decimal to hex answer or digit to hex step.
Okay.
So if it's going to print out a string of 11, no, anyway.
So here, we're going to write digit to hexstat 2. And what I'm going to do in here, I'm going to create a string that has all the hex stats in it. Actually, hex stats. And then what I'm going to do is I'm going to return hexstats.find digit. Let's see it work first. Oh, it gives me that position. Hold on. Hold on. Steal this line. So I take in a digit. Oh, it wants me to give it the string version of that digit. So I'm looking for it in there. Well, that's not going to be the right value either. Digit to hexstat. I pass this guy in a 9, it gives me a 9. If I pass this guy in a 10, why is it giving me a F? Oh, because it's not finding a 10 in there. This is going to go the other direction. So this helps us go the other direction. So if I have an A, for example, if I say digit to hexstat 2 and I give it a like this, it will give me a 10. Oh, because I'm currently returning this value. Now it'll give me a 10. Similarly, if I say give me a B, it'll give me an 11. If I say give me a 7, it'll give me a 7. So this guy will, and I say give me an F, it'll give me a 15. So this allows me to convert the other direction, right? But it doesn't allow me to go from a digit to a hexstat with find. So actually what I would need to do for digit to hexstat for find is I would just return hexstats at bucket digit. Bucket 0 is a 0, bucket 1 is a 1, bucket 10 is an A, bucket 11 is a B, bucket 12 is a C, so on and so forth. Now I should be able to call decimal to hex, passing it my 2989. And there's my BAD using my lookup. Now I actually could embed this inside of my decimal to hexadecimal rather than calling an external function. I can just put my string of hexstats in here. And then say hexstats at bucket remainder concatenated with answer. So I'm doing a lookup. So I actually just showed you something that's going to help you for your homework. But in any case, we can say, here's all of our hexstats to convert these guys to their a decimal value to its hexstat equivalent. Bucket 0 is a 0, it's a 1, it's a 2, it's a 3, it's a 4, blah, 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 9. If I pass it a 10, I'll get an A. If I want bucket 11, I get a B. Bucket 12 is a C. Bucket 13, bucket 14, bucket 15. All right, that makes some sense? All right, so now that gets us all these patterns. Well, we explored our pattern of how do we take a decimal number and convert it into another base, right? Because we can actually write this now generically, can't we? Can't I say something like, just copy this. We'll say decimal to base. This will take a decimal value. And I also need to have it take in a base. Does anybody know when, if you in mathematics, if you're what the mathematical term is for a base? You're in a math class. It's something that's in a certain base has a radix of something. So I'll just use that term here in case it ever comes in handy. So the radix is a base. So decimal would have a radix of 10. So decimal to base will be like this. And what I'll do is I'll call these guys the base conversions. I'll put in the whole alphabet there. So these are all of the different numbers that could be part of any of the bases that we're able to represent with the English alphabet. All right, and rather than divide by 16, I'm going to divide by radix. And then instead of it be calling hexstats, it's called base conversions. So this function right here will allow me to convert a decimal to any other base. So if I were to call this guy decimal to base, passing it 2989 and saying, I want that in base 16, that's where I get my BAD. But if I want it in base 17, I get A5E. If I want it in base 24, I get 54D. If I want it in base 2, I'll get a whole bunch of zeros and ones. If I want it in base 10, I get 2989. So I have a single function now that I can pass any value, any decimal value to, and then the base that I want to convert it to. And in that much code, I can move it to any base. Base 36, 2B1. And base 36 is as high as we can go. After that, we're out of Yeah, we probably would luck out here, I think, if I said go with base 37. But we would get to numbers that were too large that I would go off the end of my string. Yeah.
If we started putting random symbols in there, would that do anything?
Putting random symbols where?
In the base conversion? Like after Z, if we did like.
Oh, well, I mean, it would let us do the, but it would have to be single, like smiley faces and stuff like that. Yeah, we can invent our own thing. I think you even referenced when we were first doing this, like some of these um, games, they're called like swipe things on the smartphones. They come up with the giant numbers. They use like lowercase AA for a base, AAA, that kind of stuff. So yeah, I mean, you could put commas and question marks and stuff like that. You can invent your own representation for larger bases. You know, the joke I always use is, oh, we tried it with Klingon, but there's only 22 characters in the Klingon alphabet, which is a real thing. If you Google Klingon alphabet, it's a thing. Hopefully, does anybody in here know how to speak Klingon? It was always the funny thing. The Big Bang Theory show, they actually knew, you know, they would joke about the Klingon language, but they could speak it to each other. It was, I guess I was impressed. So in any case, yeah, I mean, by our standards, by let's call it, I don't know, mathematical standards, these are the characters that make up all of our bases between base 0 and base 36. If we want more than that, we have to probably go against a standard. So this would be our standard, even though right now we only need to go up to base 16. Base 16 gets us where we need to go. The next level that we would need past that is base 32 to keep our magic trick that I showed you, the groupings. I think I showed you the groupings, right, of octal and hexadecimal, why they're compatible. So if I have, let's do that guy to base 2. So this is the decimal version of 2989. If I wanted to convert this to hex, this number right here, this 4-bit number, it's called a nibble. This is the 1's place, the 2's place, the 4 is the 8's. So this is an 8, plus 2 is 10, plus 1 is 11, that's a B. This is an A, this is a D. So you can go from binary to hexadecimal and back very conveniently. You could also go from binary to octal and back very conveniently. Hence the reason why octal and hexadecimal are popular in computing systems, because how convenient it is to move between the bases. The next level up, if we need to expand to be able to hold larger things, it would be base 32. So 8 times 2 is 16, times 2 is 32, and after that would be base 64, and base 128, so on and so forth. But you know, base 32 at least keeps us in the English alphabet. So we do have some stretching room to go still before we run out of conveniences, and we're hoping that things like quantum computing or whatever supplants our current binary-based system before that becomes a problem. But
And to switch, let's say that 1, 0, 1, that binary number into octal, you'd split it up into groups of 3, and same for 32, groups of 5, instead of groups of 4.
correct, yeah. So if you wanted this to be, if you wanted to get the octal version of this guy, it would be that. So 1, 0, 1, this is 1's, 2's, 4, so this is a 5. This is a 6. This is a 5. This is a 5. So 5, 6, 5, 5. That's the octal version of this. Just short. It's like a quick convert, which makes it convenient for computing. All right. So questions about any of that? So in the end, we ultimately got a decimal to base that gave us the ability to a single function that can convert from a decimal number to any base. Now, that's something that we all could do, right? We learned how to do it by hand, but every single time I gave you one, it would take you, a couple minutes to kind of work it out. Isn't this pretty convenient now that we have it written? Just boom. Okay, so that's a tool we can always use. What if we were to go the other direction? So let's say that I wanted to go from that binary number to decimal. How do we solve this? Well, we have our 1, 0, 1, 1, 1, 0. This guy's in the ones place, the times 2, the twos place, 4s, 8s, 16s, 32. So this is a 32 times 1 plus a 0 times 16 plus a 1 times 8 plus a 1 times 4 plus a 1 times 2 plus a 0 times 1. So 46. And we can test that with our code. So if I say, give me the binary version of 46, we should get 101110. One zero one 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 zero. All right, so that's our pattern for converting a decimal number, or converting a number in another base to decimal. So this guy would be called binary to decimal if I wrote this. What if instead I had octal to decimal? So 137 octal to decimal. So 137, this is the ones place, the times 8 is the eights place, times 8 is the 64's place. So this is 1 times 64 plus 3 times 8 plus 7 times 1 . That's a 95. We can test that. .95 in base 8 gives me a 137. That's what we had here as a starting point. So I just went back the other direction. All right, makes some sense. Similarly, if I had BAD from hex to decimal, so this is a ones place, 16's place. So what's it, 256 place? So this would be a B times 256 plus an A times 16 plus a D times 1. A B is actually an 11 times 256 plus a 10 times 16 plus a 13 times 1. And this should give me a 2989. There's my 2989. That makes sense? So how do we solve this particular problem if we're writing kind of the pseudo code for it, working backwards? So we have a string. we know the base that we are currently in. It's given to us. So we know the current radix. This far right guy is always the ones place, times the radix, times the radix, times the radix. So if I was dealing with a binary number, this is the ones place, times 2 is the 2s, times 2 is the 4s, times 2 is the 8s, times 2 is the 16s, times 2 is the 32s. I'm in octal. This is the ones place. Times 8 is the 8s place. Times 8 is the 64s place. I'm in hexadecimal. This is the ones place. Times 16 is the 16s place. Times 16 is the 256 place. See, it's the same pattern. We just are multiplying our place by the radix each time. And ultimately what we do is we get this value. Now, notice here we had to convert our 11, our 10, our 13 into the correct value. So we had to make a B become an 11. We had to make an A become a 10. We had to make a D become a 13. Now, we saw this earlier, but just to remind you, if I have 0, 1, 7, 8, 9, if I have that string and I say find an A in it, it'll give me the 10. Find the B in that string, it'll give me the 11. Find the D, it'll give me a 13. Find the 4, it'll give me a 4. So we can use our find function to give us the decimal equivalent of a value that is, we can call them hex stats right now because that's what I've represented here is the legal hex stats in the base 16 number system, but we can go all the way up to base 36. So at base 36, we would have the entire alphabet, right? A Z would be a, what, 26? No, Z would be 36. Actually, if Z is a 36, then we can go to base 37. So it is base 36. Base 36 is the highest we can go because a Z is found at bucket 35 in that string. Okay, so for our homework, we want to write base to decimal, which takes a string as a number, as a representation number, and the radix we want to convert to, and it does the, on the radix we are currently in, and it does the conversion from that radix, I'll put base, to decimal. So BAD should become a 2989. What was my, well, I'll just leave that as an example. All right, makes sense what I'm asking you to do? So basically the other pattern from what we did in class today. We did this guy in class today. And what I'll do is I'll go ahead and log into Slack over here on my Linux, and I'll post this code in our Slack channel, everything I did today. So you have that as a, because I don't think it will let me copy between the two, will it? Yeah, it doesn't. Okay, questions, comments, concerns, bribes? All right, so look for this code up on Slack here in 2 minutes or something like that, and then I'll get the assignment put up on Blackboard. I'll see everybody on Thursday.